Hi, Roman Ibrahim. I'm going to make an additional add-on for our PLC program. Previously, we have done program and made an HVAC weekly schedule program for HVAC. This is only an add-on for a new program if there's a problem unit to modify that we can able to control temperature. Especially this application is for a big air-cooled chiller or water-cooled chiller. A delta temperature, a package unit, and a small air-cooled water chiller. The settings for the range of the delta temperature is from between 15 degrees Fahrenheit to 20 degrees Fahrenheit. Ranges between 15 to 20, it must not be less than 15 degrees Fahrenheit or more than 20 degrees Fahrenheit. A bigger equipment, air-cooled chiller or water-cooled chiller, ranging from more than 3,000 tons. Above 3,000 tons, whether a chiller is water-cooled or air-cooled, the practice of 16 degrees Fahrenheit to 22 degrees Fahrenheit. When the temperature drops down below 15 degrees Fahrenheit, then there is something a problem with the system of our chiller. If the range temperature, delta temperature, if the range of the delta temperature reaches more than higher than 22 degrees Fahrenheit, then there must be a problem with our system refrigeration of our chiller machine unit. So we are going to take up this kind of program that we can able to help the consumer, the user. So if somebody have owned building a high-rise building using a water-cooled chiller or an air-cooled chiller and using a very big tonnage of capacity of chiller to cool down the building, then this will help the client to efficiently use the power or electricity power that it will not exceed the capacity of the unit while the building are still in demand of cooling it down the temperature. Most problem of the unit when the subcooling and superheat charge of the refrigerant in the system undercharge or overcharge of refrigerant. If the unit system is having an overcharge of liquid refrigerant, it might have the same problem as well of the system unit refrigeration if the unit is undercharged. And we are now talking about the delta temperature. We are going to put an add-on program for our delta temperature of our water chiller or the air-cooled chiller or the refrigeration system. So here we are going to create an add-on program. As I have said, this is an add-on program that the PLC is receiving signal from the HVAC, from the AHU. It receives signal from the sensor of the discharged air temperature of our AHU and as well of the return air temperature of our air handling unit. So if there are differences between these two or outside the range of the delta temperature, delta T, it might get confused that delta T and delta temperature, they are both the same and we are getting it the right range of the practice and temperature difference from the return air and the supply air of our HVAC. If there's a problem outside of that range, the temperature, the refrigeration cycle of our system, we are using an equipment for a water-cooled chiller or an air-cooled chiller. Having this kind of problem, so it will easily identify the unit are continuously running without any controls, the difference temperature of the inside building are outside the practice, the right practice of that delta temperature. And we're going to make a timer count down when this delta temperature giving unequal input and output of the air, which is the return and the supply air, will process this difference temperature. And if these variables of numbers within the range, it will not be on that to trigger the timer to count down with that specific time that the delta temperature is still outside the range. If that temperature is still outside the range that required practice of delta temperature, the timer will going to count down. Let's say if I put here, it stayed here, if I'm making it like I said, 100 semiseconds. This one that timer. So if this timer, if I seated the time here that it requires, if the difference of that practice that we are having for a higher capacity of chiller machine, a bigger unit of machine requires, let us say, 4 hours. The difference, if it will not change within the period of 4 hours, if the delta T difference is still outside the range within that 4 hours, we'll count the errors of the delta temperature. If the countdown of that 4 hours still not changes the difference of the temperature, and this will be the contact timer of this timer number 20. Timer number 20 will having this not changes, it's still outside the range of that practice from a bigger unit 15 to 22 is like difference. If outside the range, it will count the timer until up to 4 hours. It depends on the program of the system or PLC. 2 sensor in a unit, the air handling unit, and this is air handling unit. This one here is a supply air temperature, discharge air temperature, and we call this one here at the back is the return air temperature. There is a sensor in place to measure the temperature of the air supply, and as well the return that having the sensor to monitor the temperature of the return air temperature. Let us say, for example, if we are reading here from our rat, and that, which is the discharge temperature, if we have supply air temperature 55 degrees Fahrenheit, the return of 75 degrees Fahrenheit. So if we're having this kind of reading in our DAC sensor, we're having this one of 55 degrees Fahrenheit and the return of 75 degrees Fahrenheit. We are going to subtract, let us say 75 minus 55, 20 degrees Fahrenheit difference. So the practice for a small package unit, minimum in the range of 20 degrees Fahrenheit maximum temperature. For a bigger unit, a bigger chiller, air cooled or water cooled chiller, more than 3,000 tons per unit, my practice is from 16 up to 22 degrees Fahrenheit. Fahrenheit. 16 degrees Fahrenheit up to 22 degrees Fahrenheit. These are the range. The unit, the chiller, or the package is in a good, efficient operation unit. It means that the system charge is getting the right subcooling of the system and also getting the right superheat. Getting both of this subcool and superheat, it gives us the right measurement of this difference in temperature of our HVAC. We can easily get the right delta temperature if we're having the right subcooling and the right superheat of our refrigeration system. Back to our program, we are going to edit this one here. This is our delta T. So when it reaches the set point, that range that it counts 3 errors, this will cut off all the supply to trigger the trip all the units operation. And to put this coil delta T arrow, the delta T differencer arrow, HMI LCD display monitoring the fault history error for HMI, we have to click this one here to make a register alarm events. So we are putting here. So this one W3.00 arrow here. Put in the workflow, this is the workflow here, 3.00. Put this one, type place alarm and set to delta temperature arrow trigger by the counter that it counts 3 times attempt of faulty error on the difference of that delta temperature within that range hour that the temperature difference does not change and still outside the range of the difference temperature. It will count the timer, it will trigger the timer to switch on the counter, and it will count the fault of how many times it fault until it counts up to 3 times. Then this counter will trigger the delta temperature error to trip off the operation of the instrument AC, as well as the outdoor equipment, water cooled or air cooled chiller machine. So when this happens, this will trigger on the set to on of address. So let's set that one. With this now. Now we are counting the timer. So here, the motor damper of the PF, the EHU is open. Then the PF motor start first, the EHU second start. HVAC is now working, and when the demand of temperature to start the compressor or the chiller, and that would be the outdoor functions and operation to function properly in an efficient way. If the refrigerant system or chiller outdoor unit is proper subcooling and superheat, is getting the right settings, then there will be no problem for our discharge air temperature and the return air temperature. If the temperature difference, the return would be coming up or going down. If the return temperature is getting up to 79 and we are having the supply air temperature of 55, the difference would be 24. So 24 degrees Fahrenheit is still not inside the right operation of delta temperature. That is above, so it means to say that the system is having problem. So it requires ahead troubleshooting and maintenance. So it must be corrected. If the unit just started running and then we are having this kind of supply air temperature while the return is still at high, it's so easy to identify the 55 degrees Fahrenheit of supply air, and the unit just started. The return is getting higher. Let us say it's still 80 degrees Fahrenheit. We can easily identify that the supply or the system refrigerant is having such problem. So it needs to be troubleshooted and checked for maintenance, other maintenance. So this one, as I have said, if the temperature difference is outside the range, the operating range of the delta temperature, we are going to monitor now the sensor of the return air temperature and the sensor of the supply air temperature read the same temperature, and it has this difference, then that equipment or that particular monitoring device will give contact to our delta T difference, delta temperature difference, which is outside the range of that delta temperature. Then this will go to close contact, and within particular hour, let us say if the difference does not change for a period of 4 hours, temperature difference does not change, then the timer will count until it goes up to 4 hours. Then he will count this one, this timer here, relay contact timer, give signal to our counter timer. As we can see here, this counter timer have a count of 3. So when he closed the timer to give this counter timer contact, it counted that there are still 2 left to go. When the system is giving that, and then it cut off within that 4 hours, it cut off. The difference goes back to its range within that range. Our timer will not count of that error since it cut off in the range of 4 hours. So still here the counter, it does not change. We still have 2 fault or 2 counts of error to go. And within the things, let us say it will count until this timer relay will give signal to the counter timer that counting this error is on a second time. Having it count for the second time, he gives a signal of fault. That's the time that the delta temperature goes back to normal, and then it counts again. We can see here that as previously, we don't have this kind of tripping here, so it gives a trip alarm. The counter here counted on the 3rd time, it gives a fault reading on the delta temperature, and we are seeing here in the LCD display of our HMI that the trip alarm caused the BHU alpha motor fail to start, the alpha motor failed to start, and the GTD damper, which is this one, failed to open due to the reason that the delta temperature or HVAC is having or receiving a wrong delta temperature range. So it requires this one for maintenance and troubleshooting of the refrigeration system, this air-cooled chiller or the water-cooled chiller. These are the design add-on program for our chiller, HVAC, air-cooled chiller or water-cooled chiller unit. It is an add-on program that will monitor the discharge air temperature and as well the supply air temperature. Getting off the right delta temperature, it gives our chiller to work on in an efficient way of operation. At this point, we cannot able to reset the problem manually. We cannot do the resetting on a PLC HMI. We have to first troubleshoot the problem, what will be the cause of the problem, and trip all the unit, and that the chiller and the EHU unit is on a tripping alarm condition. No one is working. Even we are going to reset, we cannot reset at once, so we have to troubleshoot and do the maintenance part. Here, give us an indication that the delta T already have this problem, so it gives us directly instruction to troubleshoot the problem on the refrigeration system of your unit chiller. This the system is 2/3 of the temperature, we have to knock off refrigerant into the system. That the system is on the right sub cooling and superheat with the right amount of volume of refrigerant in the system. That is the time we can able to set manually our upper unit. Doing it manually, we are going to do outside upper unit chiller the problem. After resetting the problem, that is the time that we are going